Shall we start, ma'am?
Yes, ma'am, I'm ready. Whenever you
Okay.
say.
Okay, ma'am.
Okay, so shall I
Okay,
start?
ma'am. Yes, ma'am. Let me give my your introduction,
Sure.
and welcome to all the participants.
Yeah, please go ahead.
So once again, I welcome all participants on behalf of Electronics and Communication Department of VVP Engineering College on day 5 of ATAL FDP on next generation in AI, ML, and IoT. The coordinators of this FDP are Dr. Jignesh Joshi sir and Dr. Dipesh Kamdar sir. I would like to give a brief introduction about our today's expert. I have already given an introduction about the eInfochip Aero company, and already two experts, Mr. Pranav Purohit sir and Mr. Shalin Shah sir, have delivered their expert lectures on day 3 So, one more expert from eInfo Chip Company is here with us today. Uh, Respected Aditi Joshi ma'am. She is a technical lead at eInfo Chips with over 11 plus years of experience in designing and delivering technology solutions across multiple domains, including generative AI, cloud computing, IoT, and enterprise application development. Her area of interest is in creating scalable, business focused architectures tailored to meet the needs of client and industries like aeronautics, compliance, and electric vehicles. Today, she will be delivering a session on her expertise on generative AI. So, on behalf of Department of Electronics and Communication, I welcome you, ma'am. And now the session is yours. Over to you, ma'am.
Thank you so much, ma'am, for the generous introduction, first of all. And also, I would apologize in advance because my camera is not working. I would have liked to switch on my camera and show my face to everyone, but my camera is somehow not working and I would not be able to switch on the camera. So, first of all, apologies for that. And also I would like to thank Jignesh sir for coordinating, and thanks to your prestigious organization for giving me the chance to share my learning and knowledge with all the respected professors and faculty members. So thank you. All right. So all right. So, as a ma'am has already told, the agenda of today's discussion would be on the emerging technology, and I think it is the most booming and the fastest growing technology, that is generative AI. I don't think there would be anybody now who's somehow not using it, and we are using everybody's using chat gpt, right? So it is the baby of generative ai technology only. So you are using chat gpt, or you are using llama, which is inside your mobile, which comes with whatsapp, right? And then there is google is also giving you gemini. So I think all of us, we are touching generative ai products somewhere, and it is deeply impacting us. So quickly moving on to the agenda of today's presentation, what we can expect from today's presentation is, I'll quickly walk through the journey of how generative AI has evolved. So, like the journey from AI to generative AI, that is one. Then we'll go deep dive. Then we'll take a deep dive into what is generative AI and what are different generative AI models. Then we'll briefly touch on how the model training is being done. Then we'll go deeper into one technique of model training, which is prompt engineering. There are few other techniques. If time permits, I can just talk about it based on the queries and the question that I would be receiving. And then because we are talking, I mean, and the last thing would be to discuss on what could be the careers for college students or anybody in generative AI who's just starting their career with generative AI. So I'll be touch basing on these things. Okay. So starting with the journey of AI to generative AI. So, as we all know, artificial intelligence. So, first, let us understand what is artificial intelligence and why it is required. So, artificial intelligence, any system. So, artificial intelligence, if we break this term, artificial and intelligence. So, what we are trying to do is earlier, the computer systems, they were only able to do what we had instructed. So, like we make Java programs or Python programs. Over there, if we write x plus y equals to maybe z. So if you do 2 plus 3, then it would give you 5. So whatever you are instructing, It can do only that. It cannot go beyond what you have written inside the program, right? So natural progression was the natural progression to it was to basically give intelligence to the system, artificial intelligence to system. So basically we wanted to mimic human intelligence in side the system, so that without any human intervention, the system should be well capable of taking its own decision. So any system which can take a decision, which has the power of decision making or problem solving, is basically an AI system. For example, if we just go by the example of, we all know Elon Musk, right? Elon Musk, and we are all aware of Tesla. So the self-driving car that he has created is on high level, is the example of artificial intelligence. So the complete system which makes the decision of like where what should be the speed, when to take the turn, when to stop, is the complete system, is artificial intelligence system that makes the decision. Okay. Now going deeper into, so the subset of artificial intelligence, the specialized branch of artificial intelligence, is machine learning. So in machine learning, in machine learning, what happens is, so it there is historical data, and based on historical data, the prediction is made, or basically the decision is made. So if I take the same example of self-driving car, so based on the driving data, the system should be able to recognize the people who are walking in the street, or if there are any stop signs. So based on the driving data, uh, the system should be able to recognize these things, right? So this is machine learning. Now if we go one step more deep into this direction, would come deep learning. So deep learning is advanced machine learning. So over there comes advanced neural networks, which uses complex patterns in order to in order to derive the relationship between the objects, right? So again, if I take the example of self-driving cars, so over here, the car's camera, which identify uh, different lanes, vehicles, traffic light, if the traffic light is green, red, when it has to stop, would come under deep learning. Now, uh, machine learning and deep learning, they look very similar if we see in broader perspective, but there is a difference to it. So I'll just take an example. So machine learning is like teaching a robot by showing it a lot of examples. So if you show it many pictures of cat and dog, so it is going to, and now if you show any new picture of maybe a cat or a dog, so then the machine would be able to recognize and segregate which picture is of cat and which picture is of dog. Now deep learning goes one step more into it, so it is bit more advanced, and over there the robot has the super brains with many layers. So it can also recognize the breeds of the dog, if it is a labrador, or if it is a Pomeranian, or if it is any other breed, right? So that is the difference between machine learning and deep learning. After deep learning, a few couple of years back only, we had started hearing about chat gpt, and I think um, in the technological revolution, I think the first technological revolution, again this is completely my perception, the technological revolution was the invent of computers first, then I think the advent of internet, and then I think mobile is something which has deeply affected everybody's life. And I think after that, significantly something which is disruptive in nature is, I think, generative AI. So this chat gpt was the talk of the town, and after that we see generative AI everywhere. We see deep fake videos. We see you can listen to the music of your artist, your favorite artist. You can choose a song, and then you can choose the your favorite artist, and you can just listen to that song in their um tone, the way they used to sing. So it is all a generative AI, right? So then after deep learning came a generative AI. So generative AI is a specialized artificial intelligence branch only. But in here, in generative AI, the focus is more on generating new contents like the text, images, music, and the content resembles much like human. So if we take the example of self-driving car, and if I take the example of a music system only in that car, so then if you want to create, if you want to create new music based on maybe your mood, so you can just instruct your self-driving car uh, to basically, you can just say that I am in a happy mood, create a new music for me. Then in that case, the music which would be created would be by a gen AI model, right? And if in case in and with and if I have to segregate between generative AI and machine learning, then taking the same example of music system. So suppose what we have seen is in the apps like Spotify, whenever you play a song, you get the recommendation of next song. So that is the example of machine learning. So based on your historical data and the general data over the internet, it learns that if the user is in certain mood, and there are few other parameters also, based on that it would be able to recommend your next choice. But if it is about generating the content which does not exist and it is completely new, then generative AI would come into picture. Okay, so this is how from AI we are now into generative AI. Okay. Okay, so I'll quickly move ahead. And if in case there are any questions, what we can do is we can jot down all the questions, maybe in the chat area, and then we can take all the question line by line once the complete presentation is done. So that we can do, or I'll take a pause after a logical break, and then I'll open up for questions. So that way we'll address the questions. Okay. So now we'll go deep dive into generative AI. So this is a very top level view of the generative AI system. So this is the heart of generative AI system. So over here, the large, small, and tiny uh, you see over here are basically the large language model, small language model, and tiny language models. So basically, so by model, I mean the systems which are basically responsible for generating the content. So these systems basically they get trained from a large amount of data set. The data can be labeled data also, unlabeled data also. And then in large language model, basically it is being trained with vast amount of data. And then uh, the neural network also and the computing power also that was required in order to make and train this model was extremely large, and hence the name is large language model. If you want to work with large language model, the compute capacity of your system has to be really very good. Then only you can then only this language model would run into your system. Okay. So if suppose your compute capacity is not as good as it is being expected by large language model, then there are two other flavors of language model and there are so many small language and tiny language models. So small language models are good for like general systems which are either i5 i7, and which have RAM of around 8 GB. So over there you can deploy a small language model and you can start playing around that. And if you're working with chips, then tiny language model can fit into chips also. Okay, so there are three flavors to these language models. These are being trained on the train on some training data, and then whenever you use this language model, they can generate new content. The content could be either text, image, video, or code. The other use case is they can analyze the content. So if maybe you provide a feedback, a user feedback, and you just say that what do you feel about this feedback? Okay, so okay, so it can analyze your content. So if you give some feedback, and then you just say that analyze what is the sentiment of the user, it would be able to basically summarize the complete sentiment, and would be able to tell you if the user was happy, if the reaction was neutral, or if the user was sad with whatever delivery has been done. Okay, and then it can also do the summarization. So these are the few use cases that I have written in the top level view. We'll go deep dive into other use cases later. Okay, so moving forward, now we are moving towards how the model training is being done. So the very first step in model training is data collection. So let's take example of chat gpt only. So chat gpt, now it looks like there's nothing which has been hidden from it. You ask anything and it has answer to any and it can answer everything. So how is that possible? It is possible because it has been trained with a lot of data, with all the publicly available site, with all the sensor data, with so many publicly available databases from business systems, from paper, from offline documentation also, right? So the very first step is to collect the required data. Okay, so and the data has to be like really huge, and it should be having a lot of examples of everything. Then only generally any AI system would work if you are having many examples. Then only it would be able to predict the next thing, right? So the data has to be really large in the quantity. So the very first step in model training is first of all data collection. The second step is cleaning the data. So it is a very general saying in IT that if you give in garbage, then you'll get garbage only out of it, out of the system. So the data has to be really clean. So for example, I'll just give two examples from here. So suppose if you feed in this date or this date. Now if I am also I'll also get confused that if it is in DDMM format, or it is MMDDYYY format, right? So whenever you are giving any date, you have to specify the date format also. Otherwise, or you can rephrase the date like first, then you can write you can write first, then you can write month January, and then you can do it 2024, right? So in that way anybody could clearly understand that the month was January, the date was first, and then what was the year, right? So either you specify the date format along with the date, so that the machine is properly able to understand your training data, or you have to write that data differently. Similarly, in this case also, so in example one is still okay, because over here you are specifying the time in 24-hour clock format. But over here we are not very sure if you 1:30 is if it is an AM or PM. So either you write that it is a 24-hour clock, then it is fine, that it would be 1:30 AM only. But if it is um, uh, and then if it is you are not specifying which clock it is, then you have to write AM and PM. Similarly, for example, there was a sentence. If I just say that I heard Tommy bark loudly at Ginny, so over here with bark coming over here, you one can understand that Tommy is a dog, but you never know who Ginny is. Ginny could be a girl, Ginny could be a or Ginny could be the name of any other pet, right? So if I rephrase the sentence and if I say that I heard the dog bark loudly at the cat, then it makes complete sense, right? So, first of all, you need to have data, and whatever data you have, you need to cleanse it also before feeding it to the model in order to train it. Okay, now you have now when you have data and now you have cleansed data also. Now we'll go into more technical terms of the LLM or the language model, I would say. Okay. So the very first steps that happens is that we'll take the example of the same sentence, which is I heard the dog bark loudly at the cat. Okay. So if you feed in this sentence as the training data to the language model, then the very first step that will happen is tokenization. So now what is tokenization? So in tokenization, uh, the sentence would be basically chunked. Um, uh, so uh, the process of tokenization is dividing the input into is dividing the input, and then the token could be either a word or a subword or a sentence. So now if I take the example of this sentence, it has been tokenized on the word level. Okay, so I becomes one token, heard becomes another token, becomes yet another token. Okay, and then every token is being assigned an ID. Okay, so in the process of tokenization, first you have to chunk the training data, and then you have to assign the ID to that chunk. So this process is tokenization. So now when we see this example, every word has been assigned an ID, and if you see that A has been assigned an ID 3 and A has been repeated two times. So if I have to represent this sentence in terms of ID, then instead of this A getting new ID, 3 would be repeated two times. Okay. So this is how the sentence would be represented in terms of token. Okay. And then similarly, if I have to write a new sentence wherein I say I heard a cat, then the ID would be I heard. So it would be 1, 2, a would be 3, and cat would be 8. So this is how you would be representing it. So the very first step after cleansing, taking the input, everything is being divided into token and assigned a ID. So this process is known as tokenization. After tokenization has been done, uh, okay, after tokenization gets done, then comes embedding. Okay, so in embedding, what happens is, uh, so you take each token. Okay, and just imagine that there is a vector space. Okay, so vector is like a three-dimensional representation of anything, right? So you take each token and you assign it some space in that 3D vector. Okay, and so assigning a vector value to the token is embedding, and embedding also takes care of semantic relationship between um, different tokens. So for example, now I'll just try to explain it. So for example, if dog has been assigned this as the embedding in the 3D space, then dog and cat, they are animal. So basically there is some connection between dog and cat, right? So semantically they are somehow related. So that is where in this 3D space, you would see that dog and cat, they are very near to each other, right? Similarly, bark and meow, they are sounds of animal, right? So that is where bark and meow, they in this complete 3D space, they are very near to each other. Okay. So now and then dog and bark, they are also near, and then cat and meow, they are also near, right? So that is how while creating embeddings, first there is a space which would be assigned to the tokens. That would be the first procedure. And then the other thing would be that all the tokens which have some relation, they would be assigned the space near to that token itself. Okay. The third thing would be attention. So attention is so now what we have done is we have tokenized, we have assigned IDs, and then we have placed into we have given the space also, we have created the relationship also, like we have kept the similar data near to each other. Now comes attention. So attention is, so in the complete sentence, every token would be assigned weights. Okay. So I would, so if we take this sentence only, I heard a dog, so I would also be assigned some weight, heard would also be assigned some weight, a would assign some weight, and dog would assign some weight. Now what is weight? So weight is basically the measurement unit of how much attention you have to pay to this word in the complete sentence. Okay. So basically what the machine is trying to understand is that in the complete sentence, what are the most important words based on which, around which it has to take out the meaning of the complete sentence, right? So in this complete sentence, I heard a dog, herd and dog, they would be assigned more weightage, right? And around herd and dog, other things would be associated. So that's how the machine is trying to learn and understand from the training data which has been provided to it. Okay. So now how the language model works. uh, just a second. It looks like I'll unshare my screen. It looks like that there's something which is missing in what I'm sharing. I'll share back my screen in a moment. Okay. Mm,
Unable to hear
yeah, yeah,
your
yeah.
sound.
I'm sharing back. Okay. Now I hope the screen is visible back, right? Okay. Thank you. Okay. So talking about now, I'll just summarize what we have just spoken. So now we learned how the language model works. So this is the complete chart with which we can understand how actually chat gpt or any other language model works. So we have already spoken about tokenization, embedding, and attention. Now we'll understand everything in sequence. So if I take an example, that if I have given the cat is sitting on the, is the sentence, okay? The cat is sitting on the, and this has been given to chat gpt. So now what, and if you just write the cat is sitting on the and press enter, what chat gpt would do is it would try to predict the next word which you might be thinking, or it would just try to complete the sentence, right? So that is how it is generating new content. Now we will try to understand how actually the prediction of the next word is being done with the same example. So first, what happens is, if I'll just write this sentence, the cat is sitting on the, and I'll give this as input. It would be tokenized, wherein it would be splitted into smaller pieces. It would be splitted into smaller pieces. Every word would become one token. Okay. Then embeddings would be calculated. That is, all those words are converted into numbers so that the computer can understand them, and each number represent the word's meaning in a mathematical way. Okay. So this is how embedding works. Then there would be positional encoding. So positional encoding is the language model. In embedding, what we have done is, we have created a mathematical representation. But now, till embedding, there was no information of what was the position of that token in the complete sentence. So for that, there is another position id which is being assigned. Okay. So that is positional encoding. So like, in the sentence, the cat is sitting on the would be assigned id 1, cat would be assigned id 2, is would be assigned id 3. Or in this sentence, write a story, right would be assigned id 1 because the position is 1. Would be assigned id 2, so that the model can know what was the position of each word. Okay. So now we have tokenization also, embedding also, and we know the position also. After that, there would be a series of transformational steps. So by transformational steps, I mean is that we would be taking this sentence, the cat is sitting on the, and then we would be calculating the attention. Okay. So the model would decide that which is the word it has to pay most focus or most attention to. Okay. So in the sentence that I'm repeating again and again, cat and sitting looks like the most weighted word. So on the basis of these two words, the model will try to predict the next word. Okay. And then the feed forward which is written over here, it is the process. So basically, it processes the information to understand the context and the relationship between these two words, which has been selected as part of attention. Okay. So then the complete refinement happens. Okay. And then this softmax, which is written over here, is basically a mathematical function. And uh, uh, it what it does is, it predicts the next words. Okay. And it assigns the probability to all those words. So the next word could be the cat is sitting on the mat, the cat is sitting on the table, or the cat is sitting on the roof. So it comes up with three words, and this softmax function, it assigns the probability to all the three words. So maybe the mat would be 80% probability, table would be 15% probability, and roof would be maybe 5% probability. So based on this calculation, the generative AI, it is going to complete the sentence that the cat is sitting on the mat. The sentence that we had given earlier was the cat is sitting on the, and after that we had pressed enter. After all this procedure is being done, it would come up with the sentence that the cat is sitting on the mat, and it was able to predict the next word. So that is how the generative AI model function, and that is how it is able to generate the content. So now I'll take a pause, and if there are any questions related to how the model works, I'll be happy to take it up, or otherwise I'll move to the training methodology of different training methodology which are available for model training. Okay, I'll take this as a no. Then we'll proceed to the next slide. Okay, so okay, now we have the model. So all that we have understood till now is basically what ChatGPT has already done. Okay, we don't need to do all this stuff. Okay, now when we talk in terms of models, I'll come back to my previous slide, and this is that slide which I would want to speak about. So, okay, Viren has a question. Viren, if you want to please proceed. Viren, I can see your hands raised, but I can't hear you. Viren, you are not audible to me, at least if anybody else can hear him.
Yes, hello.
Yeah, yeah, now you're audible.
Madam, regarding the semantics through which the model tries to understand that dog and cat are animals. So,
Uh,
how does the model get to know the semantics? How do we train through the? Do we have to create specialized semantic models like, let's say, understanding the mechanism of a small device like home appliance like a mixer grinder. So mixer grinder has a motor and it has a knob. So if the AI needs to understand a part or a device and where all the device, how the device is connected or assembled, and that is where the large language model will need a domain specific semantic model. So are those models created separately, or is the LLM able to learn it by itself? So there must be some human intervention where a semantic model needs to be defined. I'm asking
sure.
this because I'm working on semantic models. That's it. Thank you.
Okay, okay. Oh, that's very good to know, Viren. So over here, till now, what we have done is we have to answer your question. What we are doing is we are utilizing the models which are already being provided to us, and then we are training over them. So the procedure that I have told till now is something that has already been done by the organization. So what they are doing is they have written some sophisticated algorithms. They have used the transformer or the transformer decoder model. They have used underlying neural network, which helps in identification of the semantic relationship between those words. But they are really black box to us. What we can do is what we are doing as of now is in order to change the relationship or in order to change the weights, what we are doing is we are utilizing the fine tuning technique. Okay, so that is one training methodology that we would be discussing later in this uh, presentation.
Thank you, ma'am.
Okay, all right. So now what we have talked about is how the model works. Okay, so now we have also touched based on what are SLM, what are TLM, or and what are LLM. So here are most popular models which I have listed here, and the list is growing day by day. So over here you can see GPT-4o model, which is actually behind Chat GPT. Then you can see Gemini Nano model also. And Microsoft has also its own model, and AWS also comes up with its own model. So these models that you see under these category, they are mostly proprietary models, and they are available as a form of cloud services as of now. There are other models like Llama 3 models, which you can actually download on your system, and then play around with it and develop use cases. Okay, so these are the LLM models. Other are SLM models. So SLM models are basically the models which require lesser compute power, lesser system requirements, like 5.3 or Gemma model. So we have used a 5.3 model from Microsoft for one of the use cases, and it works seamlessly, just like large language models. And then there are TLMs also. So there are models which are actually which requires even lesser system configuration than SLM. So all these models that you see over here, actually they have gone through the technique that we were just speaking about, which is like, first the data has been fed, then the data has been cleansed, then it has been tokenized, embedding has been created, their algorithms have been made in order to decide the attention and positional encoding and stuff like that. So it has been all done in this model, and now we are getting this model from different vendors, and we can just use the services from them. So we do not have to do all the things that we have just spoken about. All these things that we have spoken about, that has already been done for us by different AI companies, and we can use these models, and then we can do uh, training, more training of these model, and we can like transform their behavior. So we'll also come up to Viren's question, how we can basically how we can basically tune the behavior of the generative AI model, but that will come in the coming up slides. So now coming on to the way of model training. So basically there are three broad ways of training the model. First one is I think very popular and buzzword, which is prompt engineering. So prompt engineering is the very first thing with which you can change the behavior of how does the model work. That is one. After that is fine tuning, and the third is RAG, which is retrieval augmented generation. So we'll go deep dive into prompt engineering, and we'll quickly just touch base on fine tuning and RAG. And if the time would permit, then I can talk about these two technologies at length. Okay. So now what is prompt? So whatever instructions that you give to your large language model becomes a prompt. So input to the chat GPT. So if I am writing any sentence, so if I am writing any sentence that write a story also, or write a story of maybe a king who likes to eat an ice cream, if I give this an input, okay, so then that becomes a prompt. So so prompt is a text or a query or an instruction or a command or a question or a request which we type, that is actually prompt. So the example of basic prompts are listed over here. So if you can just say that, write me the code of login functionality, or you can just say that you develop the complete user profile page. Okay, so this is the example of basic prompt. Now moving ahead. Okay, so now if you see prompt engineering in itself has become a job opportunity now. So we they there are and prompt engineers, I would say, they are these days they are hired on a very good pay scale. Okay, so now prompt engineering is another skill that you can highlight in your resume. That is one. And it is actually a very creative field, and you can do wonders if you actually know how to, if you can master a prompt engineering. I would say that I have created at least 3 systems only based on prompt engineering and nothing apart from it. It is, they are purely prompt engineering systems, and we'll discuss those use cases also in the coming slides. And they are enterprise level solutions. Okay, so now how we can engineer a prompt. Okay, so first the prompt has to have some role. Okay, so for example, talking in the terms of like IT only, so there are different roles assigned to engineers. So there are back-end engineers, there are front-end engineers, there are testers. So you have to say, you have to assign the AI the role that you want the AI to play. Okay, so instead of you, because the AI is working, the AI, the generative AI model, it should be knowing what role you want it to play. Okay, so you have to, for example, over here, I have written the example as a backend developer. Okay, so first, as a backend developer, I have given this a role. Now, the second thing is you have to give a task or the instruction. So instead of just writing that develop a login system, you can first give it a role as a backend engineer, develop a secure logging system. So you are providing extra information over here that you have to develop a secure login system. So you can provide extra context to it. So in here, secure is that context that you have to provide secure logging system. And then you can give a question that you can use some, you can also specify which algorithm you wanted to use for password in encryption. So there are many algorithms, like bcrypt is one of them, md5 sum is another, and things like that. So if you do not specify this algorithm, then it is then the large language model has the liberty to generate anything, right? So it is very important to be specific, and then you should be writing that how to use bcrypt for password encryption. Okay, so and you should be giving an example also. So these are the, so basically these are the elements of the prompts. Going deeper into the types of prompt engineering. So okay, so the very first technique is zero shot prompting. So zero shot prompting is when you provide no example and you just give a task description. So over here, if let's take an example and we'll discuss it with the help of example only. So the example of zero shot learning is that you are asking the large language model that the given input, if it is a palindrome string or not. Okay, so you are asking that is the following statement palindrome, and what is that statement? Was it a car or the cat I saw? Okay, so actually this is a palindrome statement. So if you reverse it, it would be equal from both the side. Okay, so it is a palindrome string. So this is a zero shot learning example. Okay, where zero shot prompting example, wherein you are not providing any example to it. Now there is one shot prompting, so wherein you would say that determine if the following statement is a palindrome, and along with that you would also provide the example of what is a palindrome. So in this case, if you see madam is a palindrome, you have given this example. So you would say if madam comes, then this should be your response, that yes, it is a palindrome. Now you would say, now you check this on the basis of same rule, same example that I have given. Okay, so this is one shot learning. In few shot learning, you would give a few more example. Okay, so you would give a happy case, you would give a bad case, then you would give a complex case also. So over here, madam is only one word. In here, this is a sentence. So basically, the machine would know, okay, you are not only referring to the word while you are asking for palindrome. Okay, so this is few short learning. Now, another technique is chain of thoughts. So in chain of thoughts, what we do is we encourage the model to explain its reasoning before providing any answer. So what we do is what we would be doing as a human, we provide all the steps to it. So basically, that is chain of thought. For example, we'll say determine if the statement is palindrome and think step by step. Okay, so we'll give the statement over here and we'll say the step one would be to ignore the cases, spaces, and punctuation. Then you have to remove all the non-alpha numeric character, and the result would be something like this. Then you have to reverse the string, and then you have to compare both the string, and if it matches, then the result would be palindrome. So that's how the chain of thought would be. So your prompt would be from here up till here, right? So this is how the chain of thought works. Then there is an iterative prompt. So iterative prompt is like you give a zero shot prompt first. So your question, your first statement might be that is this a palindrome, the statement which is given over here. Now the language model, it may say that no, it is not a palindrome, while you were expecting the language model to answer it as palindrome. So in the following prompt, you would say that check again by ignoring punctuation, spaces, or capitalization. So what you're doing over here is you are improving your prompt one step at a time. Okay, repeatedly. So that is the iterative nature of prompting. Now, another technique is negative prompting. So in negative prompting, what you do is you explicitly tell the model what not to consider and how not to respond. So basically over here, what you'll say is do not stop at the first match. Okay, and you will also specify that you have to ignore spaces, punctuation, and capitalization, stuff like that. Okay, so in negative prompting you will specify what not to consider. And then another technique is hybrid prompting. So hybrid prompting is combining multiple techniques together. So for example, over here, what we have done is we have combined it few short learning. Over here, we have given two example, and then over here is the chain of thoughts. So this way, so this was a very simple example, but believe me, prompt engineering is very powerful, and you can generate complete systems only out of prompt engineering, and you don't require anything else. So this was on prompting techniques. So the role of prompt engineering, so basically it guides the LLM to create the response. It improves the quality because and if the prompt is very I mean mature, so in that case it would reduce the mistakes, it would not hallucinate also, and then it would also manage the biases. Okay. Okay, so now coming on to the projects and the use case which are only based on prompt engineering. So I'll give you okay, so I'll give you an example from the IoT space itself. So the very first thing is the sentiment detection and request routing. So so this is this on this use case we have worked. So there is a customer, and the customer is a healthcare domain customer, and what they do is they create displays for operation theaters. Okay, so in operation theaters there are doctors and they are working in sterilized environment, so basically they cannot touch the screen once they have started the operation, right? So earlier there used to be just a display like a TV display. Okay, now they have replaced it with a smart 4K display. Now what that display is capable of doing is, inside the operation theater, first of all, that display can recognize the voice of the authenticated staff. Okay, so only if you belong to the hospital staff, then only that display is going to respond back. Otherwise it would say that you are an unauthorized user. That is one. And then uh, that is the first thing that it does. Then from that display, what you can ask is, so this was the requirement from the customer, that doctors like to hear the soothing music while they operate, right? So they asked us to have Spotify inside that device. Okay, so so that the doctors can listen to music. That is one. Apart from that, a very important requirement is that while doing the operation, sometimes there is a need to call to another doctor and to show what is happening and to take their consultation on how to proceed further. So this is also a very general case which happens inside the OT. So basically, there was a need of telephone directory first, and there was a need of so basically there was a need of a softwares like Teams. Okay, so that the doctor can make call to another doctor. And then there are other services also. There are lot many services. So basically that device has become integration hub as of now. So there are lot many services which are interacting. But coming back to the topic, how prompt engineering is helping over there is, so basically whenever doctor speaks, uh, somebody is not on mute. I'm not sure. Uh, Parvesh, Paresh. Okay. All right. Thanks for muting. Okay. So now what will happen is, suppose in the OT operation was going on, okay, and doctors were already listening to some music. Now the doctor wants to stop the music and he wants to consult some other doctor. So the doctor has given the instruction to the device, and they have told that stop the music and connect me to maybe Dr. Kunal, okay, on the other side. So now if we see, there are three things which is happening behind the scenes. First, the device has to understand that there is an instruction to pause or stop the Spotify app, whatever music is going on. So that is one. So the very first request has to route it to Spotify app, right, in order to stop the music. That is one. Another thing is to identify where Kunal is in the complete directory of Teams, and then to make a call to Kunal, to contact Kunal. So there are three things which are happening, which are basically the intention of the doctor while he speaks that sentence, right? So what we have done is we have created a prompt. Okay, so that prompt is able to direct the LLM. So basically what we have done is we have told we have engineered prompt in such a way that it can take in the input from the doctor, and then it can segregate, it can separate out all the intentions, and then it can route the request to the intended service. So it is all because of prompt engineering. Okay, so basically we were able to detect the sentiment and we were able to do the request routing. This is the very first use case of prompt engineering that we have delivered to the customer, and it is in production also. Another simple use case could be, for example, if there is some customer feedback, okay, so if there is a hotel, okay, and or in college itself, suppose there are different departments in college. So now if you receive any kind of feedback, be it good feedback, be it bad feedback, be it general feedback for improvement, now if you have created a portal wherein the parents are free to put in their feedback, what that system can do is they can take the input from the parents, and then um, they and from that input, the model would be able, you would, what you would be doing, you would be doing an intelligent prompt engineering. That prompt would be able to guide the model in order to segregate that this feedback is good or bad, and it was intended for which department. So whatever department it was intended for, we can direct the request to that department, and that the information would go to that department, that the teachers, that the parents are very happy with the performance of maybe computer science department or electronics department, especially this or that teacher, right? So that is how prompt engineering can help in sentiment detection and request routing. So this is one use case. Another use case is document validation. So we have done a very huge use case of document validation. It would take another session if I go by that use case. I'll take a subset of that use case over here. So, um, for example, in the training and placement cell, maybe in the college, if we want to segregate the resume of the student who are working on Java, or who are working on Python, or you have maybe certain skills, or what you want to do is you want to identify that at least there are few things that should be there in resume. There should be one language, either Java or Python. Then there should be address mention of the student, and then there should be contact details also, which should be mentioned, and then maybe the minor and major project that has been done, either of them. If all these information is there inside that resume, then that resume would be considered valid, or otherwise it would be considered invalid. So what you can do is you can create a prompt, intelligent prompt, and you can that prompt, what it would do is it would take the complete resume text as input, and then that prompt you would engineer in such a way, you will give example of what the skills look like, what could be the languages and stuff like that. So it would take your resume, it would try to figure out if all those information was there in that resume, and based on that it would say that if it is a valid document or if it is an invalid document. So that is another use case. I'll take these two use case combinedly, remote response generation and knowledge extraction and summarization. So for example, let's take this meeting itself. So whatever I am saying, and if you want to float it out to somebody else, so this meeting is already on recording, right? So the transcription is already getting generated with the transcription service which is being provided by Teams itself. Okay. So what you can do is you can provide the complete transcription to the language model, and you can create a prompt. Okay. Uh, Asking it to extract all the intended information you want and to summarize it. That is one. And then after that, maybe you want the summary to be sent to the students, and you have the list of student. Okay. So in knowledge extraction and summarization, what we are doing is we are taking the transcription from the complete meeting notes, Okay, and you from the meeting, and then we are converting it to the meeting notes or the summarization. And then the other thing that you are asking is now, this could be a chain of thought over here. So why I am saying chain of thought over here is because over here, first what you're doing is, first you would be generating the summary, and then you would be asking the LLM whatever is the summary. You take it up, and then you generate an email to the respected student. Okay, so now you have provided the list of student also. So maybe the list of student, so there are three student you want to send this mail to. One is Aditi, another is Aarti, and third is Yasha. Okay, so you are also saying then send the email to these three students, and you can write the content also according to the summary which has been generated. Okay, so it would be based on the student name. It would be creating the body of the email also, that Yasha, this is the summary, or Aditi, this is the summary. And it can also, and if you provide extra information that if Aditi belongs to computer science, if Yasha belongs to electronics, it can summarize and produce dynamic content based on that information. So that is all the magic of prompt engineering. And the third thing is entity extraction and automation. So basically this is something which we are using in order to automate the complete pipelines. So there was a use case wherein what we need to do is, uh, first we need to validate. So what we would be getting is a document. Okay, so those document, they would be containing some information related to the purchase detail. Okay, so what was required was to extract out the information of all the items which are being listed in that invoice. And then after that we have to create some object like JSON, and we have to send that JSON to somewhere else. So basically, out of like maybe a 10-page document, I am only concerned with the data of only one-page document, wherein all the information of the things which have been purchased is written. So the prompt should be such that you should be able to identify the information which is intended. You should be crafting the prompt in such a way, and then you should also be giving the instruction of how do you want the output to be. So if you want it in a JSON format, you can do that, and then you can route it to the other entity, uh, 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 to the other entity for automation purpose. So these are few projects of prompt engineering, and there could be n number of projects for prompt engineering. So I would pause over here, and I would like to discuss the questions which are from prompt engineering, and then maybe we can move forward.
Yes, any participant have any questions, you can ask directly.
Okay, I'll take it as a no, and I'll move forward. Okay, so one thing was prompt engineering. So in prompt engineering also, there is one challenge that if you don't create prompt correctly, you won't get the expected output. So you have to be very careful in creating in the instruction that you are giving to the LLM, and you have to be very mindful of creating the prompt, and you have to apply all the techniques that we have used in order to get the best results. So that was one challenge with which we can overcome. We can overcome that challenge. The other challenge is that Chat GPT or any generative AI model, it is trained on it is trained on the data which is till certain date, right? So if you ask very latest data question to Chat GPT, it would say that I was being trained till this date, and I don't know anything after it, right? So lack of up to date information. So that is the second challenge that we face. So in order to overcome this challenge, we have another training technique, which is RAG, which is retrieval augmented generation. Okay, so I'll only quickly touch base upon how RAG works. Um, so Okay, so over here, let's see the example. If I say that how many how was India's men's cricket team performance in recent World Cup? So how what would be the answer that I would be getting is that as of my most recent updates is like October 2023. So this is the screenshot that I had taken earlier. At that time, generative GPT-4o model was trained up till this date only. So it would give me the information only till that date. So now, if I want to overcome this challenge, how can I do that? So if you have any specific data, right? So what you can do is you can have your own data. So, for example, I'll take the example of a student's data only. So, I'll take the example of university student data. Now, we maintain this record right now either in some database or in files, right? And or there are softwares which have the details of all the students. Now if there is some case wherein you need to find the history of the student. So for example, there was some case wherein parents are claiming that they have not received the documents from the university, while the university says that the document has been already given to the student. So maybe this is the use case wherein you have your customized data. Okay, and now if you want to check if this has been done, either there would be a manual process where somebody would be checking in the records if the document was handed over to the parents or the student, or there would be some software which would be basically answering this question. But uh, this problem can be solved by RAG, which is retrieval augmented generation technique. So now what you can do is, so suppose Aarti's parent, they come and they say that you have not handed over the documents of my children, of my child to me. Okay, so you can just write in plain language. So for what you can do is, first you have the data, you can upload the data. We'll discuss how we can upload the data to the model. Okay, and then you can just write the question that were Aarti's document handed over to somebody, and then the model would respond back with a yes, no, and all the proofs that are there, and you need not have to search in the complete database. So all that manual thing would go away. Okay, so a very good example of this are the custom chatbots. So for example, the manuals. Okay, so right now we are doing a lot of projects related to RAG these days. So over here, so there is a company which specializes in creating eyes related equipments, so the eye testing machine. Okay, so now what happens is the operator who basically operates that eye testing machine, sometimes in remote areas like villages, they sometimes do not know that what is the function of what is the function that has been given inside the machine, sometimes they are confused. So what they do is they call their customer care executive and then they ask how to basically do this thing. Okay. Or they have to go through the lab manual. So now what we have done is we have taken the complete lab manual, we have trained the model, and now that person, the operator in the remote area, he only types in the question and he gets the response from the lab manual. He does not has to contact the operator also. He does not has to go through the lengthy lab manual also. So that is the power of RAG. So basically what you can do is you can take your custom data and you can feed in that data, and based on that data the model is going to answer you back. Now how this can be done in terms of like what would be the technology components that you would require over here. So the heart of this RAG implementation are two things. First is LLM that we are already talking about since long, and another is a vector database or embedding database. Okay, so what would happen is, so embedding database is nothing. So for now, you just consider embedding database is very similar to relational database. Okay, so in relational database, we maintain all the information in terms of table, row, and column. Okay, and we maintain the relationship. Okay, and that is mostly in the format that is human readable, right? Uh, Vijay, yeah, thanks. So, okay, so which is generally human readable. So it could be string or integer, something like that, right? So now, if we replace the RDBMS with vector database, so it is an embedding database. So with embedding database, what I mean is the embeddings that we have seen in earlier presentation, wherein all the words are being represented by their numerical um, identity. Okay, so this vector data, in this vector database, everything whatever you give is being tokenized and is stored in form of embedding. Okay, so what you can do is you can feed in your custom data. So for example, when we are talking about the complete university student data, you can feed in um, the university students data into this vector database. Okay, so and then so now the data has been fed into the vector database. Okay, so that data has gone to the vector database. This is the first thing, this is the part of pre-processing that we have to do. Now what happens is so suppose let's take another example wherein we are feeding in the important lectures, the summary of important lectures which have been delivered by the faculties and the expert in the college. And now we have opened up this portal for the students and they can just go and they can retrieve the answers based on the lectures. Okay, so now what would happen is suppose there was uh, so now the student questions. Okay, so the question of the student would become the input and that would be a prompt. Okay, now this prompt would, again what it would do is it would be tokenized and embedding would be created of the prompt. So if the student says that give me the lecture of uh, teacher Kavita for maybe TOC, and in there also if the student mentions any topic from TOC, so then uh, the input would be first, embedding of this complete input would be created. Okay, and that embedding would be then searched across this vector database. Okay, so it is very similar to relational database only. In relational database also, we go and suppose we do a query with like, and we say that give me the results of all the students whose name starts with A maybe. Okay, so all the students with the initials as A would come as result, right? So similarly, because we have converted the prompt into embedding, we can directly take this embedding into vector search database, and then the vector search database would return us maybe top 20 results. Okay, which were very similar to what you were asking. Okay, so this is what the vector database would do. Now all these results, all these 20 results, they would be taken to the language model. Okay, so they would be taken to the language model, and then now you have create then you would have written a prompt over here. So the prompt would be that over here you would be instructing the LLM that you are a system who is designed for basically seeing the lectures of the teachers, and then based on the query you have to give the most relevant lecture, and you have to also pay attention to what is the subject, and if there is any lecture number, or if there is any mention of a specific faculty member, stuff like that. So you have to create prompt in such a way so that the prompt is able to filter out the most suitable result out of the 20 results that the vector search has returned back. Okay, and then based on the filtering from the prompt, the LLM would be generating the response back in such a way which is understandable by the student, and it would return back the response. So that is how the retrieval augmented generation works. So in retrieval augmented generation, you need to have custom data. Custom data is fed into vector database. From vector database, you do a search query. Search query would in turn return a lot of data. That data would be filtered by LLM with the help of the prompt, and then the LLM is going to return back the correct response. So that is how a RAG model works. And currently, if I say the industry trend is everywhere you would see the RAG model, and mostly the RAG model is for support purposes only. Okay, so one example that I have taken was of this thing only, that how maybe if you don't know how the mobile functions, you can just write how this mobile function, and if you have a lab manual to it, you can just upload the lab manual to the LLM, and LLM would inform you back in the human understandable language. The last and the third technique is fine tuning, where okay, so the very first technique was prompt engineering, where with the help of prompt we are able to change the we are able to basically direct the behavior of the LLM. With RAG, what you can do is you can upload the custom data to the model, and you can get the answer back of your custom data. Okay, now third thing is fine tuning. Fine tuning is like if you want to change the behavior of the model itself. Okay, so model is trained on some data. So chat GPT right now is trained in certain way. Now if you want chat GPT to behave differently altogether, okay, so suppose you want to create a model which is very good in providing excuses. Okay, so it has the specialization. So this is the model which is very good in creating excuses. So now what you have to do is, so there are a few APIs which are being provided by all the models. So there is certain way of how you can do fine tuning, but in fine tuning, the essential thing is you have to create a lot of examples. Okay, and you have to assign weights to them. Okay, so what you would do is you would give the input also, and you would give the output also. So for example, right now you have taken a model, and it is a general model that you have just downloaded from internet. Okay, and now if you ask it to write excuses, maybe it is not capable right now because it was not trained on such data. Now what you want to do is you want to change its behavior, and you want to give excuses for any situation. So now you would start creating the examples. So maybe you would just say that if somebody asks for my number, just say that I don't have a mobile, things like that. Or if somebody says that uh, 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 I am on leave, so what could be the excuse? The excuse could be that somebody in your family is not well, or things like that. So it is a master at creating excuses, so you'll have to provide all those examples. Okay, so over here also there is an example of music system. Okay, so what we are instructing with all the fine tuning examples is that if you receive the input with the meaning open, then you have to execute the command, this execute open. Okay, if you receive any input meaning close, then you have to execute this command. Okay, so so this is the input, these are the inputs that we had given at the time of fine tuning, and then we have run through that fine tuning API and the complete procedure. And internally the weights were changed. Okay, the embeddings were given different definition. Internally the weights were changed, and then when we told that your input is begin. Okay, so it was able to map this begin with start, and after that it was able to give that this execute play. Okay, so this is how fine tuning works. So in fine tuning, what you want is you want to change the inherent behavior of the model itself. Okay, so this is the third methodology of training the model. Now, I'll quickly, because the time is already over, I will quickly cover the two remaining slides, and then we'll uh, open up for questions. So I'll quickly discuss the growing potential of generative AI job market. So by 2027, it has been projected that it would be a $407 billion market. That is one. And then the demand of AI professionals would uh, increase by 75% since 2022. And the source is LinkedIn. Apart from that, if I talk about job market statistics, according to CAGR, there is expected growth of 35% from 2023 to 2030. And I have specially mentioned the role of college student in AI field. So they can be AI ML intern, they can be data analyst. Prompt engineering is a very budding job role. And then there are junior AI developers. So these could be the job roles. And in order to prepare the students for generative AI skills, first, uh, Python is always the preferred language because it is an open source language, and the community, the AIML community is huge over there. There's a lot of support, and almost all the modules of AIMLs are there in Python. So Python is the preferred language. There are few libraries which are mentioned over here. They are preferable, like NumPy and Panda, and matplotlib for data manipulation and visualization. So student knowledge of these library is good for the student. Then they should be going through a few AIML frameworks like TensorFlow and PyTorch. Then what they can do is they should also be knowing technologies like OCR, how you can extract the information from image or the scanned copy or PDF. So that is that is why Tesseract or Easy OCR libraries that are being already provided by Python itself. So they should be aware of that. And then as we have already spoken about RAG, so there are open source RAG database like Pinecone, and there are few others which they can play around with. Prompt engineering, they should master that skill, and then they can build very small projects. And what they can do is, first they can build the projects for maybe what we have discussed. If they want to feed in the resume and they want to validate what is the right resume and what is not. Okay, that could be one. Apart from that, they can create chatbots, and they can, what they can do is, they can create, they can take any historical information, they can feed in that information, and they can take out, and they can create something like chat gpt out of that information. Okay. And yeah, there are image generation models also, but they are costly, so I would not for college students maybe. And if and there are use cases for text summarization. The one that we have discussed is maybe this thing. Text summarization is very useful to us also. So whenever we are doing any meeting with our clients and prospects, we use the text summarization for creating the MOM. So yeah, things like that. So these are the essential skills that anybody should be having if they want to prep up for generative AI jobs. So I think with that, I'll take a pause from my end, and I'll be open for questions.
Yes, all participants, you can now ask the questions to ma'am if you have any.
Hello,
Yeah,
Yes,
I
sir,
can.
please.
Please go ahead.
I'm Dr. Brahmpal Singh. Actually, dear ma'am, I have some students who have non-engineering background and they want to
Uh-huh.
learn Gen AI. So can they
Okay.
learn?
Yes, sir. Gen AI, they can learn. The very first thing is prompt engineering is something which is related to Gen AI. That is one. But that is absolutely non-technical. All they need to know is what is the basic of prompt engineering. And then another thing is English. Yeah. So prompt engineering is a very budding job role, which has been all around. So I would say prompt engineering is something for non-technical background students, and you can promote that. And apart from that also, if they are interested in Python, I mean, if they are interested in this languages, any kind of language, so there are multiple courses in Udemy and in YouTube also, from where they can self learn also, sir. So you can just ask them to go through Python basics. And then you can just ask them, you can create a project using Python and prompt engineering. And sir, I would also, there is one information for college students I would like to give. There is one roadblock I see. What we do in our industry is, generally we use cloud services, and in cloud services they are costly, right? So that becomes a roadblocker for the students because they cannot use cloud services. So there are two things I am not very sure. If they want to go for cloud services, they can opt for free tier cloud services. So all the major cloud providers like AWS, uh, Google, or Microsoft, they provide this thing. And then there are facilities for, there are educational grants also for teachers and the students, so that can be availed. That is one. If somebody wants to go for cloud services, that is one. And apart from that, at least in case of generative AI, as we were discussing about the small language and tiny language models, that those models can be downloaded on your system itself, sir. So what you can do is you can learn Python. One, that is one. You don't need to have any support from cloud. Just like any other library, you or Python or Java that you download and install on your system, you can just download these models which are open source and available over the internet, and then you can go ahead with the development of them with them.
Dear ma'am, can you tell me that is there any online platform or best platform for the students or teachers so that they can learn online also this generative AI? Can you tell me if
Sir, I would say YouTube only, there is a lot of content. So if you are asking about free platform, is YouTube, and Udemy if you have subscription to Udemy. So Udemy, you would get multiple. I mean, we had also, when we had started learning, we had taken courses from Udemy itself, and it was only like our first step towards.
Udemy means Udyami? You are saying Udyami, Udyami.
Udemy, sir. I'll write the name of the platform in the chat window.
Okay. Right. Okay, ma'am. Thank you.
Yes, sir.
Yes, any other questions?
Sir, can you share the yesterday PPT also, sir?
Yes, it will be shared as soon as we receive from the expert.
Okay. Thank you, sir. Thank you.
Yes, anyone would like to ask Aditi ma'am any further questions?
Hello.
Yes,
Yeah.
sir.
Ma'am, one question is there regarding the chat GPT.
Mm-hmm.
Like most of the students, they are making projects on the project files based on the chat GPT, and they are collecting data from through the chat GPT, and they are making the files.
Mm-hmm.
So through plagiarism tool, it is not possible to identify the plagiarism in that case. So how we can deal these type of problems?
No.
Sir, I right now I don't have an answer to that. I mean, what I do is I promote the usage of these tools because I am working on Gen AI technology only. So in how it is very difficult to identify the difference between the output which has been generated from AI and a human. So, sir, this is a challenge that we are also dealing with, and I don't have an answer right now. But I'll go back and I'll see if I'll be having any answer. Maybe at the time when I'll be sharing this presentation, I'll be sharing my response also. But right now, I do not have the answer to it.
Yes, any further questions? As nobody is asking the question, I would like to thank you, Aditi ma'am, for sharing your valuable inputs.
Thank you so much, sir. Thank you so much for giving this opportunity.
Thank you, ma'am.
Yeah. All right. Okay.
Thank you, Aditya.
Thank you. I'll be sharing this presentation with Jignesh, sir, right?
Yes, ma'am. So once you share it, we will share it with the all the participants for their kind references.
Sure, sir. All right. Thank you so much, sir. Thanks,
Thank
everyone.
you
Have
so
a
much,
good day.
ma'am.
Bye.
Dipesh, sir.
Bye bye.
Dipesh, sir.
Yes, sir.
Any photographs we need to take?
Just Sharon Madam once she was
Oh.
joined.
Okay. Okay, all participants, before we proceed towards the second session, I request all the participants to turn on their cameras for a photo session for a few moments. I request all participants.
All participants, please turn on your camera for a while.
Again, I request all participants to please turn on your cameras. Ramdar sir, is the snapshot taken or do we need to wait?
Sorry, my mic was off. Yes, it
Okay.
was taken, and I request all the participants to turn off their mic and cameras.
Okay, all participants are requested to turn off their cameras and mute their mics. Now I would hand over to Sneha madam for introduction for the next session.
Thank you so much, Sharon madam. A very good evening to one and all present in the FDP. We are soon to start our second session.
Ma'am, your mic is muted. Sneha madam, your mic is muted.
Thank you so much, Sharon madam, for handing over the session to me. A very good evening to one and all present in the FDP with us. So we are soon to start now with our second session, and we have the privilege of having with us the expert from Kevit Industries. Dhruman sir, are you there?
Yes, ma'am. I'm here. Can you hear me?
Yes, you are very much audible. Yeah. So
Okay.
I would like to briefly introduce everyone to our expert for the second session, was Mr. Dhruman Bhadesia, the co-founder and Chief Technical Officer of Kevit Technologies, which is based at Rajkot, and it is a technology who is a Dhruman sir is a technology leader specializing in artificial intelligence and cloud computing. With expertise in conversational AI, machine learning, and scalable systems, he builds transformative solutions that drive business innovation. His work integrates cutting-edge AI technologies with platforms like AWS to optimize performance and enhance the customer experiences. Passionate about the AI ethics, automation, and generative AI, we are fortunate to have him today evening with us for the session. He has committed his career to the advancing AI-driven transformation, and he welcomes the collaborations to explore the limitless possibilities of AI and its role in shaping the future. Thank you so much, sir, for being with us today, and we are waiting for your insight